Hi everyone, welcome back to my channel, Mathematic Girls Party 3226. So yes, I'm back with the previous year solved examination questions. So of course, I have already made one video that is part 1. So in that, I have covered what questions had come in 2016 10th board exams, of course for maths, right? So this is the continuation of that video because in that I had only covered section A. This video, like in this video, I'm going to cover section B. So yes, I'm just making section wise video so that the video will not be very long for you to watch and you can watch in one take only. Okay, so let's start with the video and let me share my screen. So yes, I'll just take you through this, what I had covered in the last video basically. So yes, this is what I had covered in my last video, section A, where we had done some questions on circles, some questions on trigonometry, some on like one on AP, arithmetic progression and probability and so on. Now today we are going to start with section B. This is the second part of the video. If you have not watched the first part of the video, then I'm gonna put the link in the description box for that particular video. Go and watch that video first and then have a look at this. Okay, so let's start. As I said that this is going to be section B, so let me just show you the first question. Oh, okay, 1 second. So the first question is this. This is the fifth question because I have already covered 4 questions. So, yes. So this is our fifth question. And this is the question. Okay. So yes, as you can see, the question says, this is the fifth question of section B, 2016 paper. So if -5 is the root of the quadratic equation 2x square, okay, this is not x2, this is x square because here it is looking like x, the base is 2, but no, it's power 2. So 2x square plus px minus 15 equals 0 and the quadratic equation px square plus x into k equals 0 has equal roots, find the value of k. Very simple question and very straightforward. What do we have to do? We will start with the first sentence, which is given. If -5 is the root of the quadratic equation. What is the quadratic equation given? We have a given quadratic equation. Make sure when you are writing a board examination paper, make sure you are writing every given information. Okay, whatever is given in the question, the very first thing that you do is write down all the given information. So the very first given information is that we have the equation given, the quadratic equation given, that is 2x squared plus px minus 15 equals 0. Now, it is also given that -5 is a root of the quadratic equation. That means -5 will satisfy this equation, right? What is -5? X is -5. So if I'm taking this as Px, okay, this as Px, then because -5 is the root, so X is nothing but -5. So let's find out. So this will become 2 and then -5 whole square plus P into -5 minus 15 and that equals 0. So I'm writing here 0 and that I'm writing like this, 0 equals. This will become -5 squared, which is 25. 25 into 2 is 50. Of course, minus is plus, so we got plus sign. Now this will become plus minus 5p and this is minus 15. Now this we can write down as 0 equals 50 minus 15 is of course 35 and this is minus 5p. Now here what we can do, we can shift the minus 5p to the other side. That is the rule. If you're shifting minus to the other side, it will become plus. So minus 5p is on the right hand side. We are shifting this to the left hand side. So minus 5p will become plus 5p. Yes. So this will become 5p equals 35 as it is. And now here this will become 35. Of course, here 5 is getting multiplied. So if you're shifting this to the other side, it will become, it will get divided. So divided by 5 and that is 7. So we got the value of P, but we have not got the answer yet because in the question says, we have to find the value of k, right? So let's go ahead. Now there is another information given. First of all, we have another quadratic equation, and it is px square plus x into k equals 0. Let's write down that. So px square plus x into k equals 0. Now this is another quadratic equation that we have been given, right? So px square plus x into k equals 0 has equal roots. Once it is saying that it has equal roots, it is basically giving us something. Do you know that whenever we have equal roots given in a quadratic equation, that implies that its discriminant is going to be 0. Now the question is, what is discriminant? I will tell you. So, oh, okay. So its discriminant equals 0. Okay, so let's find out what is discriminant. First of all, let us convert this into the standard form of quadratic equation, because we already got the value of p, which is 7. So this will become 7 and then x square plus x and then into k that we have to find equals 0. Now this we can of course write down as 7 into x square, 7 x square, and then plus 7 into x as 7x. And then of course we have k also, right? So this we can write down as 7kx square plus 7kx equals 0. This is what we have got. Now, as I said, that whenever we have this condition that discriminant equals 0, so first of all, let me tell you that if this is the standard form of a quadratic equation, ax square plus bx plus c equals 0. Now, if this quadratic equation has equal roots given, that means its discriminant is equal to 0, right? This implies only the discriminant is 0. Now, what is discriminant? It is b square minus 4ac equals 0. So let's find out what is b square here. See, this is in the form of ax square plus bx plus c only. C is not here, that means c is 0, right? So what is a? First of all, a is 7k. What is b here? B is also 7k. And what is c here? C is nothing, that means c is 0. Now let's use the formula. Since it has equal roots, that means since you can write down, since it has equal roots, this particular quadratic equation, therefore its discriminant is going to be 0. That means d is equal to 0. And what is d? It's b square, that means 7k whole square minus 4ac, that means 4 into 7k into c, which is 0, equals 0. Yeah. Okay, so now we are getting 49k square, right? 49k square, and this will become c is 0, right? So 0, and this is 0 equals 0. So from here, what we are getting? 49k square 0, and 49k square 0. That means we are getting k square 0, and if we are getting k square 0, that means k is 0. So we got the value of k, which is 0, right? So, okay, I think there is one mistake I have done. Here, this is not getting multiplied. Okay, there is a mistake in the question. Okay, yes, that is why it is not correct. Here, this is not into k, it is plus k. That means c is given k, all right? So it is plus k. And here c will be k. Yes, yes, yes. Okay. So c is k, that means b square minus 4ac. Okay, I have to change this. So, okay. So let me erase this. There was a mistake in the question. It is the plus sign is missing. So 49k square minus 4 into 7k into k, because c is of course k. So this will become 24 k square, right? Yes, we got it. 24k square. Now what are we getting? We are getting 49k square minus, not k squared with this. Okay, I think there is one mistake. This is 4 into b square minus 4ac, right? So 4ac, let me just check this. 4 into a into c. Okay, yes, because that k was not getting multiplied, so this k will get like we have to erase this. Okay, yes. So there is a mistake in the question. I figured it out just now. Anyway, so let's do this. 7 and this will become 7 only. Okay, a lot of things are there. Okay, and this one is okay. I'll just do one thing. I will just check this over here only. See, I will make you understand. Here it is plus sign, that there is a misprint in the question. Okay. So now this will become 7x squared plus x plus k. That means 7x squared plus 7x plus k. That means 7x squared plus 7x plus k. Now this is fine. Now A is of course 7, B is 7 of course, not 7k, just 7. And C is k. Okay, now it's fine. So B square, that means 7 square minus 4AC. That means 4 into 7 into K. Now this is correct. Oh, yes. Finally, we are at the correct answer. So see, sometimes you will get a misprint also, but not in the board exam. Okay, this must have been corrected in the board exams. Okay, so 7 square is 49, and then minus 7 into 4 is 28k equals 0. Now very simple. We will just move. Like we will just send this minus 28k to the other side, so this will become plus 28k, and now this will be equal to k equals 49 upon 28, which is 7 into 7, 49, and 7 into 4, 28. So we got the value of k, which is 7 upon 4. So the value of k we got is 7 upon 4. And this is the answer. Okay. Finally, we have done this. Now let's move to the next one. Okay, let me just change this to the ruled line because that will look better. Well, anyway. Okay, so now I'll show you the next question. The next question is our sixth question, and that question is on the section formula. So let me first show you the question. So, yeah, there we go. And that is our sixth question. Okay. All right. What is happening? Check. Okay, the question is not being pasted. One moment. I will just do one thing. Yes, okay. So I have just added another page. I think some error, something happened. But anyway, I have taken another page and let's do the question over here. Yes. So yes, this is our next question, which is a question based on section formula. So let's do this. I think I'm able to cover a few questions only in today's video. But anyway, so yes, the question says, let P and Q be the points of trisection of the line segment joining the points A and B. Okay, so first of all, let's draw a point A and B. Now I'll be super fast. So we have a line segment, okay? Oh, all right. So I have drawn a line. So this is a line segment. I have converted a line into a line segment now. Yes. So point A and this is a point B. All right. Now the coordinate of point A is given, which is 2 comma minus 2. And coordinate of B is given, which is minus 7 comma 4. Now let P and Q be the points of intersection. That means P is here and Q is also here. It is trisecting this line segment such that P is nearer to A. That means P is nearer to A. That means let's write down P here. This is P, and there is another thing which is Q. So let's write down Q over here. Okay. So now P and Q be the point of trisection of the line segment joining the points A 2 comma minus 2 and B minus 7 comma 4, so that P is nearer to A. We have to find the coordinate of P and Q, right? So the very first thing that we are going to do is we are going to give the name to P, which is let's say x1 comma y1, and Q is x2 comma y2. Okay. So, okay, now because it is saying that it is trisecting, okay, because it is trisecting, that means this part, and this part, they all three are equal. Okay. Now P basically is dividing the line segment AB in the ratio 1:2, and Q is dividing it into 2:1. Are you understanding what I'm saying? See, let us just forget about Q for time being. Okay. So suppose on this line segment there is only A. There is only P. So now this P is dividing this line segment AB in the ratio of 1:2. That means from here to here it is 1, and from here to here it is 2. Okay. So for P, we will use a different formula because in that case, the ratio is something else. So let's start the solution. So let us consider first P because we have to find P and Q both. So for coordinate P, because of course P is dividing the line segment AB into the ratio of 1:2. So we can write down the ratio as M1, which is 1, and M2, which is 2. Okay. Now let me tell you the formula. The formula to find out the point, okay, the coordinate on the line segment is, it is given by this formula. P equals the coordinate of P, of course, that is M1 into X2 plus M2 into X1 upon X1 plus X2. One second, not X1 plus X2, M1 plus M2. Yes. And then, comma, we have M1 into Y2 plus M2 into Y1 upon M1 plus M2. Okay, this is the formula that we are going to use. So here what is X1, X2 and what is Y1, Y2? So of course here this one is X1. Okay, I'm writing here, and this one is Y1. This one is X2 and this one is Y2. So let's use the formula. So of course M1 is 1, so 1 into X2 is 7, so minus 7, plus M2 is of course 2, so 2 into X1 is 2, so 2 upon M1 plus M2, that means 1 plus 2, comma M1 Y2, so 1 into Y2 is 4, please check this, here Y2 is 4, and then plus M2, which is 2 into Y1, which is minus 2 upon M1 plus M2, which is 1 plus 2. Yes, and we got the coordinate of P, and that is minus 7 plus 4. I'm just super quick here. Minus 7 plus 4 is going to be minus 3 upon 2 plus 1 is 3. And this one is going to be 4 minus 4, which is 0 upon 3. So what is the value of P? What is the coordinate of P we got? The coordinate of P we got is minus 3 upon 3 is nothing but minus 1, and this is 0. So we got the value of the coordinate of P, which is minus 1 comma 0. Now similarly, we can find out the value, the coordinate of Q as well. But remember, in case of Q, now you forget P. So that Q is basically dividing the line segment AB into a different ratio. That is dividing into the ratio of 2:1. Okay. So for Q, M1 is 2 and M2 is 1. I hope you are getting this. Okay. Yes, I'll just make you understand once again. See, when we're talking about Q, just forget about P, right? So in that case, this part is 2, this part is 2, and this part is 1. Okay. Why we are just doing this 2 and 1, 1 and 2? Because it is trisecting. That means there are 3 parts, right? Okay. And why P, like when we are talking about P, why this part was 1? Because P was nearer to A. See, P is nearer to A. That is why. Okay, let's move to our Q coordinate. So yes, for coordinate of Q, we have M1, M2, we got it already. X1, Y1 and X2, Y2 is of course the A coordinate and B coordinate. So A, X1, Y1 was, let me write down, it was 2 minus 2. That means X1 is 2 and Y1 is minus 2, of course. And the next one is B, which is X2 comma Y2. And of course, that coordinate was given as minus 7 comma 4. All right. Yes. So of course, we are going to use the same formula to find the to find out the coordinate of Q. So to find out the coordinate of Q, the formula is of course the same. I'm directly writing down the values. So M1x2, that means 2 into minus 7 plus M2x1, that means 1 into 2 upon M1 plus M2, which is 2 plus 1, right? So make sure when you are solving this, when you are writing this, you also you use one, you write down the formula once. And then of course, M1y2, that means 2 into 4 plus M2y1, that means 1 into y1 is minus 2. So minus 2 upon 2 plus 1. Now we have to just simplify this and we'll get the value of coordinate of Q. So this one will become 2 into minus 7, which is minus 14, plus 2 into 1 is 2, upon 2 into 2 plus 1 is 3, and this will become 8 minus 2, which is 6 upon 3. So we got the answer. Minus 14 plus 2 is of course minus 12, which is minus 4, because minus 12 by 3 is minus 4, and this is 2. So we got the coordinate of Q, which is minus 4 comma 2. So this is the answer for coordinate of P and coordinate of Q. Now let's move to the next question. So I'll do one thing because I took time in just rearranging some questions because there was some misprint also in the question. So I'm going to just cover 3 questions in this video. The rest I'm going to cover in my next video where I'll be covering the entire thing. So yes, let's just do our last question, which is a proof question. So for that, let me show you the question. And yes, so this is the question. So in a figure 2, a quadrilateral ABCD is drawn to circumscribe a circle. That means circle is inside and the quadrilateral is outside. With center O in such a way that the sides AB, BC, CD, and DA touch the circle at the points P, Q, R, and S respectively. We have to prove that AB plus CD equals BC plus DA. Now, the very first thing that I want to tell you here is whenever we have a circle, okay, whenever we are talking about a circle and we have a line which passes the circle through one point, that line is called nothing but tangent. Okay. Now, suppose there is another line, okay, there is another line like this, which is passing through, okay, just write down like this here. There is another line which is going like this. Then just remember one thing, that the length of the this, for example, this is A, this is B, this is C, and this point where it is touching, it is P, and this point it is touching, this Q. So in this case, remember that AP is equal to AQ. Okay, this is a theorem, and the theorem is whenever we have tangents drawn from an exterior point to a circle, they are basically equal in length. This is a property. Okay, so this property you are going to use, and if you want, you can also start your proof. Okay, you can also start your proof by just writing the same reason in the very beginning only. Since tangents drawn, okay, since tangents drawn from an exterior point, since the tangents drawn from an exterior point to a circle are equal in length, therefore, we can see here so many tangents. So therefore, can we not just write down? Yes. So you can see here that we can write down ds. We can write down this ds equals dr, right? ds equals dr. Now, again, we can see other tangents as well. So the next we can write down as cr equals cq. One second, right? Okay. Oh, one second. Let me share my screen once again. It sometimes happens. Okay, yes, I'm back. Okay, so now, yeah, that was the screen. Oh, everything, like few things got erased. Okay, so yes, since tangents drawn from an exterior point, and then the reason I had already written, so I'm just going to start with the equation. So can I not write down that AP equals AS? Yes, I can write down AP equals AS. I can also write down BP equals BQ. Tangent, right? The property of the tangent, BP equals BQ. Also, I can write down CR equals CQ. CR equals CQ. Let's write down CR equals CQ. And the last one, as you can see, we can write down as DR equals DS. Okay. So this DR equals DS. So let's write down DR equals DS. Now let's just give every equation a name. 1, 2, 3, and 4. Now we are just going to add equation 1, 2, and 3, and 4. So 1 plus 2 plus 3 plus 4. What are we getting? We are getting AP plus BP plus CR plus DR equals. I have added the LHS part. Now I'm adding the RHS part, which is AS plus BQ plus CQ plus DS. Yes. Now just check what is AP plus BP. If you just look at the picture, let me show you. Let me do this. Yeah. If you just look at AP plus BP, this is AP and this is BP, right? If I just add this, is it not AB? Yes, it is AB. Now next is CR plus DR. Can you see CR plus DR is nothing but CD? So AB plus CD. Now we have AS plus DS. Can you see AS plus DS, which is nothing but AD? Yes. Now next is BQ plus CQ. Can you see BQ plus CQ is nothing but BC? And can you see that this is what we wanted to prove? We wanted to prove AB plus CD equals BC plus DA, and we have proved it. And that's the proof. So in this particular video, I have covered only 3 questions. Yeah, there are, I guess, few more questions in this particular section. So I think there are 2 or 3 more questions in this particular section, which I'm going to cover in my next video only. So in that, I'm going to cover the section B, the remaining questions, as well as the section C. So I hope you understood the 3 questions in today's video, and there is no doubt. I know that there were some things which could have been avoided, but because, if I'll just do those things, I have to do a lot of things. But yes, I hope you were able to understand every single thing that I explained. Let me know your suggestions in the comment box so that I can work on my videos. Yes, thank you so much for watching. And if you have not subscribed to my channel, please, please, please subscribe to the channel. Thank you so much once again. Bye-bye.